Okay, we're into the last chapter, chapter 23 on sustainability. So at the end of this, you should understand that human activities are considered when we determine ecological footprints and what that actually is and how population size can influence our impact on Earth as well. Know what what resources humans rely on and what the benefits and costs of each are with those different resources, define sustainability, and how we can actually live more sustainably. So your chapter focuses on this little town called Greensburg. I think it's in Kansas. And essentially the tornado leveled it and they decided that they're going to rebuild green and live a lot more sustainably. So they're actually like a really great example of a sustainable town, and it cost a little bit more to make them green, but now they're saving tons and tons of money. So what are we talking about when we talk about sustainable or when we say the word sustainability? Sustainability is just using Earth's resources in a way that is not going to permanently destroy or deplete them. So we're living within what's called our biocapacity. So that biocapacity is the ability to sustain human demand given available resources. So we'll get into what like ecological footprints and stuff are in just a second, which is what you're calculating this week as well. But basically, to live sustainably, you're living in a way that you're not just getting rid of all the resources we have. So ideally, to live sustainably, you want to be using natural resources. So raw materials that you get from Earth that are considered valuable, even if they're unmodified or if they're in their natural form. So farmland, gasoline, oxygen, all of those things are natural resources, right? But we use them in ways that aren't necessarily natural. And this is part of the way that we can calculate our ecological footprint. So ecological footprint just measures how much land and water is required to supply the resources a person or sometimes a population. In our case, we're calculating our ecological footprints for ourselves, right? Our individual. But it's how much land and water that you need in order to absorb the waste that is produced. Okay, so all the resources that you consume and assimilate the waste that it produces. That's what your ecological footprint, it includes a carbon footprint in there as well. But ecological footprint is human demand on Earth, and our biocapacity is the amount of supplies that are available to meet that demand. We measure this in something called global hectares. And basically that gives us the biological productivity of an average hectare. So it's how much resources essentially are within it's a hectare is just a measurement essentially. So how many resources are in that little space of land? And to give you an idea, in 2008, so it's been some time, our global hectares globally, it was 12 billion. So at that time with our population, it was about 1.8 global hectares per person is what they needed to, or what they were assigned essentially that could support their resources. But the average ecological footprint of a person in 2008, of an average person, was 2.7. So our deficit there was already over, or just under, I guess, 1 global hectare. You can see that the patterns of consumption vary pretty greatly, right? And we know in the US that we've got a pretty high ecological footprint and we have pretty great consumption. But why in the US are we similar to, let's say, a developing country, right? A developing country might use less resources and it might have a much lower ecological footprint, but because they have a much higher population, they might actually have a very similar footprint to a more developed country like, say, the United States or China, or India is still sort of developing, but it is pretty developed. So that's why you see similar footprints in these places. And overall, our current lifestyle of our human population is considered unsustainable because the biocapacity of Earth is less than global ecological, right? So, just to drive that in, biocapacity is less than your average eco footprint. Sorry, I know that's really terrible writing. So this is partially because we're using lots of non-renewable resources. So non-renewable resources are energy that we get from things that can't be renewed. So fossil fuels, oil, coal, and natural gas. Once we burn them, they don't turn into anything else, right? They've burned and they're done essentially, and they're turning into greenhouse gases, but they're not turning into something that we can use again. And the way that we live requires lots and lots of energy, especially in the US. We have such a big ecological footprint, right? So it contributes to our overall ecological footprint. It definitely contributes to our carbon footprint, and it releases lots of pollutants. So again, we see lots of carbon dioxide, but also sulfur dioxide and nitrogen dioxide, which are what cause or contribute at least to acid rain, and also arsenic and fluorine, which can cause bone and lung disease. So lots of different diseases that are coming about are becoming more prevalent as well because of the increase in using some of these non-renewable sources. When this town was built in Kansas and even across the US, we have something called a LEED certification, and it stands for Leadership in Energy and Environmental Design. And basically, it just means that the building is pretty green, right? So they're using more renewable resources like solar or wind. They have maybe water catchment devices. They have a recycling center, lots of different things that make them more of a green building. And so they can get this LEED certification. And there's different buildings even on Oahu that have this as well. But it means that they're sustainable by design. So like this town has the highest per capita concentrations of LEED certified buildings in the country, which is pretty crazy when you think about it's in Kansas, because that's not somewhere that you would necessarily think of a really sustainable place or a sustainable town. But again, a big part of this LEED certification or being sustainable in general means that you're generating energy from renewable resources. So remember, our non-renewables are things that can't be turned into something usable, right? So like fossil fuels, natural gas, but our renewable ones are natural resources that are replenished after use. So like solar panels, but solar energy, wind, hydroelectric, geothermal, um, as well as something called biomass, which is like wood or landfill gas, or burning of municipal solid waste, which is something we do on Oahu, and we'll talk about at the very end. So this is a way that we can renew our resources and keep using them forever, essentially. And a big problem that we're seeing is we're using all sorts of unsustainable and non-renewable resources, and we're requiring so much energy, but our population is also growing exponentially. If you remember, exponential growth just keeps going and going, and eventually we kind of have to have something logistic, which grows kind of exponentially at first, but then hits this thing called a carrying capacity, right? And there's lots of different reasons that our population has been growing, right? We've had the advent of agriculture, which means that we can feed more people. We've had the Industrial Revolution. We have all sorts of new technology. We have antibiotics, the discovery of antibiotics. We have improved sanitation. All of these things that are helping people live longer, helping people get around more and have more offspring essentially and be more successful, which to some extent is good, right? But it's really bad sustainability wise because we're just needing more and more resources essentially. So this population can keep growing exponentially, but it's eventually going to need to level off when our resources become limited. Oops, sorry. Resources become limited. So that is when all of this is going to have to level off at some point. And we're starting to reach that now where our resources are really becoming limited, and we're seeing different problems throughout the world because we are running out of some of these sources. We're also seeing a great loss in biodiversity. We talked about biodiversity before, and it's just basically having a number of different species and how many of those species we have, how many individuals within the species. So we talked about how many mass extinctions we've had and that we're possibly in the midst of another one. And a lot of people think it's human induced or human caused, because our rise in human population is correlating pretty well with loss of biodiversity. Remember, correlation does not equal causation, so we don't know for sure, but it is pretty crazy to see extinction rates and loss of biodiversity happening in such a short period of time. Because remember when we talked about those mass extinction events before, they happened over sometimes hundreds of thousands of years, but definitely over hundreds or thousands of years. So they took a long time to go through the whole mass extinction, whereas now we're seeing it within a lifetime. So this is happening much faster than it ever has before, just like climate change. So if all this bad stuff is happening and we're not able to use, or we keep using non-renewable resources, why don't we use renewable resources, right? And the gist of it is essentially that it's so expensive. So a lot of these technologies are more expensive, and it's based on oil, coal, natural gas. These things are cheaper because our economy and our world say that they should be cheaper, essentially. Otherwise, they really wouldn't be. But we're also, our technology's not quite there. They are still working on it to kind of get it better. And it's limited geographically, right? Wind and solar power isn't something that's readily available in every part of the world. Some places are more windy, some places are more sunny, etc. So it's a lot harder to be able to store and transmit this energy that is produced from renewable resources like wind and solar. So it's kind of difficult right now to push this, mostly again because it's expensive and the technology isn't as good as it could be, because honestly, a lot of people aren't really putting a lot of stock into it because we already have things like fossil fuels, even though they're causing lots of problems. Okay. And you might have heard of something called carbon offsets, and it's kind of the same idea of being carbon neutral, essentially, and it's that you try to counterbalance your fossil use. So you will do something to counterbalance how much fossil fuels you're using. So you might plant a bunch of trees to kind of help out with absorbing some of that excess carbon dioxide that you're doing by using more fossil fuels. This is something you guys might want to take a look at on your own. It might be something that you see on the exam, but these are sort of different renewable resources. Again, solar, wind, nuclear is actually a renewable source, although there's positives and negatives to it to some extent. Hydroelectric, geothermal, biomass. Again, with the geography, geothermal is difficult, right? Because you have to have geothermal energy. It has to be happening from a magma layer, so it has to be essentially near volcanoes, right? So look at what these different renewable resources are and why we can't use them more. And again, most of it boils down to that they're expensive, but some of it is geographically limited as well, or the technology is not quite there. Just a few more. And overall, when we look at the US does use some renewable resources, and luckily we're getting a little bit better, right? But for the most part, our top three are all non-renewable. So we use oil, I think is about 37% of our energy, natural gas is about 29%, and coal is about 16%. So renewable resources are very, very low. Again, our top three are oil, natural gas, and coal. So you might want to remember those for the exam as well. I'll write them out too. So oil, natural gas, and coal. And this is probably pretty, I guess, you probably know this already, right? And you hear it talked about most of the time, and you hear different people pushing for this, and different people pushing for renewable resources. And I don't personally know why, well, I know why it's got political, is because it has to do with money, right? And you wish these things wouldn't get political and it would just be for what is the good of the world and the good of our resources. Non-renewable resources are doing really bad things to our environment, our ecosystems, to our atmosphere, but they're also non-renewable, which means that once we use them, they're gone. So we need to start looking into renewable resources, whether we like it or not, because eventually we are going to run out of resources, which is when we start seeing that exponential growth level off and probably drop pretty significantly. Water is a natural resource and it's also renewable, but keep in mind it's really high demand, right? So when we're looking at different places, like I don't know if you guys have been in the Southwest, but Lake Mead is fed by the Colorado River, and it feeds fresh water to almost all of the southwestern United States. And you can see where the high water mark was and how low it is right now. It's at a historic low, which means that they're facing really bad droughts and they might run out of fresh water in the whole southwestern United States, which is California, Arizona, New Mexico. All of these states, Nevada, aren't going to have water. So this is something that's an issue because even though water is renewable, it's not readily available in all parts of the world. So when you're looking at being more sustainable or having a LEED certified building, you've got to pledge to basically believe that every drop of water is precious. And so you can use things like aquifers, which is like an underwater source of rain. They also have different water collection sites. Sorry, I tried to draw it on the screen for you and it switched and I can't go back. But different water catchment basically. So you'll see places where maybe you don't even have running water where you have more water catchment. Like say if you've been on Big Island in different parts, and this is everywhere, but on Big Island you'll see lots of people that have their own water catchment because they maybe don't have as much access to water, even though they've got water pretty readily available. So when we're looking at this map, this is essentially freshwater and what their overall water risk is in different parts of the world. And you can see the dark red and even some of the red is really high risk. And basically those are the people or populations that are going to have less access to fresh water. So by 2025, which is only a few years away, about 2/3 of the world's population is going to be in areas that has moderate to severe water stress. So really severe droughts that are going to be hitting these places. And even though some of the rest of the world is going to have ready access to water, it's going to be very difficult to get it to these people in these areas, which you'll see some of these areas are really, really heavily populated. So that is a huge problem. Okay, so what can you do to live more sustainably? And you guys have heard of some of this, right? So drive less or, drive electric cars, take the bus, use compact fluorescent light bulbs instead, reduce your water use, eat less beef, or meat in general. Again, our agriculture and livestock production is a huge increase in overall greenhouse gases. Recycle or don't even use different plastics. A big one is also reducing vampire energy. I'm not sure if you've heard of vampire energy, but vampire energy is essentially that anytime any of your electronics are plugged in, they're using energy. So say your TV is plugged in, and obviously when you're watching TV, you're using energy, but even when you're not watching TV, it's using something called vampire energy. It's still powering that TV even though you're not watching it. So you're wasting lots of energy to that. And that's about 5 to 8% of a family's electricity use per year is vampire energy. So like if your fan's plugged in or your lamp, all of that is vampire energy even though you're not actively using that appliance at that time. So again, you guys calculated out your ecological footprints and you know what it means. So you know how much or how many Earths it would take to support you individually or maybe you as a family. So it's all about kind of working to try to lessen that. And US, obviously, we're not doing too hot for the most part. In the Earth's biocapacity, you can see the US, how high we are compared to some of the other places. But again, they do have similar footprints just because they do have really large populations in some non-developed or developing countries, essentially. Okay. So why do we have such a large footprint? We use a lot of stuff, right? Our diets are really heavy in animal products. We tend to be pretty heavy carnivores. We package and process everything. We don't locally consume things. When people say buy local, there's a reason for that, right? You're using less resources. You're supporting your local economy. You're supporting your local businesses. All of that is a good reason to buy local, and it all has to do with sustainability as well. It's not just about the economy. They go hand in hand, which is why I'm kind of confused why this turns so political. So please don't take any of this as political action or political sway on my part. It really is just about the science and the sustainability of what we're talking about. We also have really poor public transportation. If you look at places like Europe, right? You can go on train anywhere versus here. I've never even been on a train in the US that wasn't like a tourist attraction, essentially. We also have lots and lots of waste production, and stuff like this happens because of things like Amazon.com. Amazon, right? Every time you ship something, one, it's being shipped. That's a huge carbon footprint because you're probably shipping it via airplane. Airplane travel, whether we're traveling or shipping things, is a huge footprint because using the fuel that airlines have to use is substantial. So not only are you having a big footprint from the shipping, but it's also packaged in all this plastic stuff that will never go away, right? Plastics never go away. This is an interesting video. Again, you can't really see it on here, but it's this lady who collected 4 years of trash, and her 4 years of trash are in this tiny little jar here. So it is an interesting video, might be worth watching. I don't think it's very long, but it's a cool video, and I'm not saying to go this intense, although it would be great. I'm not even at this level. It's really hard not to produce that much trash, and you have to be very, very conscious of everything, and you have to give up a lot, which is unfortunate. You shouldn't be put in that position. Hopefully, as a global economy and the way that we start doing things, hopefully we start to get more to the place where we're not producing as much trash on the business side so that you don't have to make really expensive or conscious decisions to avoid it. So when we talk about reduce, reuse, recycle, or even refuse, this is kind of our hierarchy, right? So reduce is kind of up here towards the top, although refuse should really be the top part, right? If you know, like say someone offers you a straw, the best thing is to refuse it, right? And then next you would reduce it. If you can, you reuse it. Or if you really can't do any of those three things, that's when you recycle it. So just a little bit about how we deal with waste on Oahu, because it's kind of interesting and you should know what's happening. I think we've talked about it a little bit before, at least in the marine debris lecture, but we have a waste to energy facility. It's called H Power. And basically most of our garbage on Oahu is being burned. So all of that heat from the fire is actually boiling water. And from that boiled water, we get a bunch of steam, and that powers turbines that then generate electricity. So we can transfer all of that electricity to the public grid for general use. So we do actually get some energy out of burning all of this waste. And that's a good thing. It's a good thing that at least we're getting something out of it. Is it a good thing that we're burning a bunch of waste? I don't know. We do have a bunch of scrubbers and different things that are taking out really harmful things that are going into our environment, but it'll be interesting to see data on that, because I'm sure that no matter how much stuff you have extracting the bad things that are being burned, I'm sure some of that's still getting in the air. And you're also losing a lot of nutrients. Like say you throw away a bunch of food, instead of that food, those food nutrients going back into the soil and being put back into the INA to be able to grow more plants or whatever, to feed more animals. Instead, it's just being burned and essentially lost. So there's positives and negatives, but at least we're getting some energy out of it. There is still quite a bit of trash that goes into landfills here as well. Okay, so H-Power, and I think this is a little bit old, it's probably a little bit more now because they're trying to increase the amount that they can process, but it's about 3,000 tons of garbage, which is about 8% of our energy right now. Again, I think it's a little bit higher now, but that saves us, even just that 8%, over 3,000 barrels of oil per day. So that's pretty substantial. Even if burning trash is maybe not the best thing, at least we are saving a bunch of oil. So it is kind of a trade-off.